Hello, welcome to episode 8.C, is it? I think. And today we're going to be talking about motion in more than one direction with drag. So I'm only going to focus on two degrees, or 2 dimensions, because adding the third one is relatively easy, because Z kind of just acts the same as X. So we're going to think of, let's suppose we had this. I'm going to draw this actually here, right here. There we go, keep it straight. So suppose I let this go at some point, and we have our curve. So x1, y1, and this is t0, t1, x0, y0, and this is, well, actually this bottom axis would not be time. It would be something, it would be x, but we don't have to worry about that for now. I don't think it's not that big of a deal. So what can we do with this? Well, this is going to be some r over t, right? So if you remember our vector curves, we're going to have some parametric function describing our motion. This is going to be x at t, y at t, right? And we want to consider linear drag. So all we're going to do is basically copy paste our formulas from last time. X naught plus, what was it? V naught e minus t over tau. No, e naught 1 minus e minus t over tau. And y naught plus our terminal velocity, that's a terrible plus, better, times time, plus tau v terminal 1 minus e minus t over tau. Okay, and so this is this parametrically describes our motion. So let's suppose at some time, so this is t naught and this is t1, right? So let's suppose we want to describe, we wanted to find the height, right? So wanted to find y1 given x1, right? So we want to find the height along our path, right? Given some position, right? And actually I should write this. This is VO in the x, and this is going to be VO. I just completely wrote this completely incorrectly. I'm gonna have to draw a big black one here. And just erase this whole thing. Yeah, and let me retry this one. I made this color, so this is actually v naught y plus v terminal. There we go. 1 minus e minus t over tau. Okay. Never mind. Yeah, so I want to find y1 given x1. Right, so how would we think about going about this? Well, we can write this equation. So we have x1, so r at t1, let's go to x1, y1, y at t1, and x and y at t1, and that is going to be x naught plus v, our initial velocity in the x, minus 1 minus e tau minus t1. And then in the y, we have y naught plus our terminal velocity at time t1 plus, and then obviously we have all of these at and then time t at time t1. So what can we do with this? Well, we can actually, so if you notice, we actually have one t1 variable here. So what if we solved for t1 and then replace, right? Because this is a system of, we have a system of nonlinear equations, but this isn't actually too difficult because these equations don't, this doesn't have, this only includes this t1 variable, which we can solve for in the x. So let's go ahead and do that. And if we do that, so we get, I'm going to just write x1 is equal to x naught plus vox 1 minus e minus t1 over tau. And so we get t1 is going to be, so we take x to the other side, minus x1, then we're going to divide by vox, and then we want to subtract 1, and then we're going to multiply by negative 1. Oops, subtract 1, then we're going to multiply by negative 1, and then we want to take the logarithm, right? So when we do that, we solve for t1, and we are going to get negative tau times natural logarithm of x1 minus x naught over vox. And from here we can, and obviously we could swap these if you wanted to. I'm not going to, because when you plug it in, it actually helps. So what happens, and actually this is negative, I keep forgetting that. Keep getting those signs incorrect. And I need to find a better marker. There we go. There we go. So let's go ahead, substitute this in. And so we got minus v t1, and that's going to turn into v terminal tau natural log of x1 minus x naught over vox. And in the bottom you have e to the minus t1 over tau. This is going to turn into e to the negative tau over tau times the natural log of x1 minus x naught over vox. Well, these cancel, and all we're left is with this guy. So this becomes x1 minus x naught over vox. So when we substitute this in, we get y1 is equal to y naught plus VOW plus VT times x1, or am I missing something? Oh, right, I forgot this one. We have to have this, we have this plus 1 term in here, which I completely forgot about. So yeah, we got plus 1, and then plus 1. So VT, and then we're going, this goes 1 minus x1 x minus x0 over VOX plus 1 plus tau V terminal natural log of x1 minus x naught plus 1 over VOX. Right? And so obviously these terms cancel out, and we end up with y1 is equal to y naught plus VOY plus our terminal velocity over VOX times x1 minus x naught. And actually this is subtracted. My bad. And we add our tau VT natural log x1 minus x naught over VOX plus 1. And let me just double check my notes to make sure that that looks correct. And right. So I actually made a mistake here, and that is this is not a plus 1. This is actually minus tau natural log of 1 minus x1 minus x0 over VOX. So we just do that. We replace all of these. Replace all of these, and this becomes 1 minus that. And we can substitute all of this stuff back in. This becomes a plus, and this becomes basically the same. And we just want to change the color. So it is now 1 minus x1 minus x0 over VOX. And yes, and now that should be correct. That should be correct. I got the order wrong, trying to skip steps. So next we'll go into solving, using this to solve equations and things like that, because it's obviously a bit long. Oh, and one thing to notice is this is also, we have an x in here inside our natural logarithm and an x outside. How are we going to solve for y? That becomes tricky, but we'll deal with that later.